Hi everybody. Today I am going to show you how to find the inverse of a function graphically and also algebraically. First of all, we need to know one thing about a function: is it one-to-one or not? So to do this, here I have taken two graphs. If I draw the horizontal line, so we can see that this horizontal line intersects this curve at one point. Here intersection point, that is only one by this line. This line also making only one intersection on this curve y equal to x cube. But when we go for y equal to x square, horizontal line intersects this curve at 2 points. Here also this line intersect at 2 points. But here everywhere only 1 point. So here I have written no horizontal line intersects the graph more than once. So we can call this function is one-to-one, but this is not one-to-one. But to get inverse of a function, we need one-to-one function, because one-to-one functions is important because it is precisely the function that possesses inverse functions. So let's see in the next slide more details of how to find the inverse of a function graphically, but function must be one-to-one. Here our graph function is y equal to function of x. If I make a horizontal line, so on this curve it intersects at one point. So surely this function has an inverse function because it is one-to-one function. Now I am drawing the reflections of this function. It is y equal to inverse fx or x equal to fy, and there is a line which is passing through the origin and it has a slope 1, and the equation is y equal to x. Now if the coordinates of a point, say I am taking one point here and one point here, to do some proof that this one is the reflection of this in y equal to x. So what I'll do, I will take a point here. Taking one line PQ, I have taken points P equal to AB but Q equal to BA, because we need to get inverse function here as a reflection of this one. So if the coordinates of a point P equal to AB are exchanged to give those of a new point Q equal to BA, then each point is the reflection of the other in the line y equal to x. This is very important point we need to understand. So to understand that, say PQ has a slope -1, because this PQ, if it is slope is -1 and this slope already I told y equal to x, value of m here, y equal to mx, m equal to 1. So this line slope and this line slope, if we multiply, it will be -1. It means it is perpendicular. So PQ is perpendicular on this. So surely we can find the midpoint of this a plus b by 2 or b plus a by 2 or a plus b by 2, which lies on this midpoint here. So the graph x equal to function of y, this one, according to this, x equal to function of y, it is blue, is the reflection of the graph y equal to function of x, it is red, in the line y equal to x, light blue. Very important point to understand. Again, since the equation x equal to function of y is equivalent to y equal to inverse fx, the graph of inverse f, this one, graph of inverse f, this one, are the reflection of f. So it means f and inverse f are reflection of each other in the line y equal to x. We have to understand this. More formally, we can say to obtain the graph of inverse fx reflects the graph of fx about this line y equal to x. So in different way I said to get the clear picture. So we got it. So we know now how to get the inverse of a functions graphically. So in the next slide we will see an example. Say I am taking an example, function of x equal to square root of 2x plus 1 is invertible and find its inverse. So let's draw the graph of these functions, and it is easy to get this function because first let's see the graph. Say if you put x value 0, then y equal to 1. So here x is 0, y equal to 1. So this point. Again, if I put x value minus 0.5, so minus 0.5 multiplied by 2, it will be minus 1 plus 1, so y will be 0. So it is this point at a distance of minus 0.5, this point. So we got this point, we got this point. Now if I put here say 2, it will be 2, 2, 4, 5. So square root of 5, it will be some positive value somewhere here. If we put 3, it will be 7. It will be value somewhere here. So we know now what will be the shape of the graph. This curve. We understand now. So our curve is okay. Now question is, we need to find the inverse of this function algebraically. So how to do that? And also f is 1 to 1, I put here one horizontal line. So what we understood, like I explained in previous slide, here it is intersecting at one point. So surely this curve is, this function is 1 to 1. And it has an inverse function. So what I'll do now, I will draw a line y equal to x to get the reflection of this. reflection of this, and we are sure that the equation here, what will be the equation here? Let's see first algebraically what are the inverse function comes. That inverse functions we can put it here. Say this is y equal to square root of 2x plus 1. If we do it square on both sides, it takes this form. Now inverse to be obtained by, here I have to follow these two steps. Solve the equation for x in terms of y. So let's do that. Transposing for x, we get x equal to y square minus 1 by 2. What about the third step? To express inverse x as a function of x, interchange x and y. So we interchange x and y. What does it mean? Here we got this equation by transposing for x. Now interchanging x and y means x, in place of x we will put y, in the position of y we will put x. So we got our equation y equal to x square minus 1. This is the inverse function. So surely we can write inverse fx equal to x square minus 1 by 2. So this is the inverse function. Surely we can shift this value here for this curve, because this is the reflection of this one graphically, and we solve it. We solve this value algebraically. So we are done for this part.